Yesterday we have seen the electronic configurations and few questions we have seen yesterday. Just we revise that, then we'll go through this. So we have got 3D series, 4D series, 5D series, 5D series and 6D series. In 3D series, 4s orbital fills up and 3d orbital gets filled up, right? In 4d orbital, 4d series, 4d orbital and 5s orbital gets filled up. Here 5d orbitals and 6s, here 7s and 6d orbitals get filled up, right? So electronic configuration lies between 1 to 2 and this is 1 to 10. So this is what we have seen yesterday. But so 3D series belongs to the fourth period. The fourth period of the group. So this belongs to the fifth period. The highest n value gives us the period number. So this is the sixth period and this is the last period, that is seventh period. Right? So every series has got 10 elements each. So this is what we have seen, right? So yeah, so we'll move on. Next we'll go to properties, right? So how exactly it looks like? So first one we'll talk about some periodic properties we have to check, right? So we will see the periodic properties. Physical properties పైనే క్వశ్చన్స్ వేస్తారమ్మా. కెమికల్ ప్రాపర్టీస్ క్వశ్చన్స్ ఆర్ రేర్లీ ఆస్క్డ్ ఫ్రమ్ దీస్ చాప్టర్స్. సో పీరియాడిక్ ప్రాపర్టీస్లో వాట్ వీ హ్యావ్ టు చెక్. సో ఫస్ట్ వన్ ఈజ్ అటామిక్ సైజ్. సో దిస్ వాట్ వీ హ్యావ్ టు సీ. సెకండ్ వన్ ఈజ్ అయోనైజేషన్ ఎనర్జీస్. థర్డ్ వన్ వీ హ్యావ్ టు సీ melting points and boiling points. This is what we have to see. Fourth one is, so these elements have special properties like multiple oxidation numbers. Multiple oxidation numbers, right? So these things we have to check. Fifth one is nature of oxides. Nature of oxides we have to check. At the same time, what else we have? We have E0 values, potential values, electrode potential values we have to check, and few more properties are also there. The formation of alloys, alloy formation, and the last one is interstitial compounds. So these are the things we have to learn here. Okay, so first we'll start with atomic size. So the very first we'll start with the atomic size. చెప్పండి అమ్మా, అటామిక్ సైజ్ ఎట్లా ఉంటుంది? సో ఫస్ట్ విల్ లెట్ us talk about the atomic size. Atomic size, yeah, we also call it as radius. Atomic radius and ionic radius दोनों चेक करना है, right? Okay, so how can we do this? చెప్పండి అమ్మా, అటామిక్ రేడియస్ ఏమవుతుంది? సో జనరల్లీ ఇన్ ఏ గ్రూప్ atomic radius increases. Atomic radius increases. In the period, atomic radius decreases. Antenama, this is the rule what we have studied. Because when you go down to the groups, what will happen? What happens exactly? A new shell, the new orbit is being created. So that's why the size automatically increases in a group. So first element has got only one orbit, second element has got two orbits, third element has got three orbits like this, fourth element has got so four shells like this. That's why the size increases. The distance between nucleus to outermost orbit keeps increasing. So nucleus to outermost orbit keeps increasing. But the thing in the పీరియడ్లో ఏమవుతుంది చెప్పండి? పీరియడ్లో let us talk about fourth period. Let us talk about the fourth period. So in fourth period starts with which element, Amma? Fourth period starts with potassium, right? Followed by calcium 20. Then comes the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So this is the fourth period. So చెప్పాలమ్మా ఫోర్త్ పీరియడ్లో సైజ్ ఏమవుతుంది? సైజ్ ఆటోమేటికలీ డిక్రీజెస్. సో దీని తర్వాత విల్ గో టు ద we enter into the P block elements, right? So the general rule is this only: the size from left to right of a period decreases, but the decrease in the size when you move from in D block elements, when you move from left to right, the size decreases, there is no doubt in it, but the decrease in size is bit less as compared to representative elements or main group elements. So what is that meaning is here? The size decreases, no doubt here, but the decrease in size is less. So very less decrease is found. Very less decrease is seen here. So this is what you have to remember. What is the meaning of it here? Let us say potassium is this much bigger. So then the calcium will be like this, right? So then comes the scandium. So then comes the titanium. Then comes the vanadium. So then comes the chromium. చూడండమ్మా ఏమవుతుంది? సైజ్ డిక్రీజ్ అవుతుంది, బట్ ద డిక్రీజ్ ఈజ్ వెరీ లెస్. రైట్? సో దిస్ ఈజ్ scandium, this is titanium, vanadium, chromium, manganese, this is iron, then comes the cobalt, then comes the nickel, so then comes the copper, थोड़ा बड़ा होगा शायद, then comes सबसे बड़ा थोड़ा जिंक होगा. So ऐसा कुछ होगा. This is copper, this is zinc. So what can you observe here? What can you observe from here to here? ఇక్కడ నుంచి ఇక్కడికి చూడండి, సైజ్ ఇక్కడ నుంచి ఇక్కడికి, ఇక్కడ నుంచి the radius from here to here is, let us say this is 100 centimeters, sir, 100 picometers. So this is going to be 50 picometers. And from here to here, the distance is decreasing. I hope you have understood with my diagram. అర్థమైందమ్మా? ఎవరికన్నా చెప్పండి, ఆన్సర్ చెప్పండి. There is a decrease, but the decrease is here. What is the decrease? 50 picometers is the decrease here. But here the decrease, let us say this is like 30 picometers. So this is going to be 29 picometers. This is going to be like 27 picometers. This is going to be like 25 picometers. There is a decrease in the sizes, but the decrease is found to be almost very, very negligible decrease is found. So that's why the atoms of the D block elements have got almost same kind of sizes, right? So this point you have to identify. So this is you have to identify. इसका reason भी मैं बोलता हूँ. There are two reasons. So इकड़ा D block elements लो कुछ भी properties के बारे में पूछे तो आपको यही reason बोलना है. So one is D orbital, D10 configuration, incompletely filled D10 configuration, and lanthanide contraction. So these are the two reasons. Okay. So this is the size. Hope you have understood this. అర్థమైందమ్మా? right? The atomic radius decreases from left to right of the fourth period. The same trend is observed in every period, in fourth period as well as in fifth period as well as sixth period also follows the same order. Now we'll go to fifth period. Yeah, fifth period has got, so we have got fifth period lo undi potassium, rubidium, right? So rubidium, calcium, strontium, then comes yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, right? So palladium, silver, and the last comes the cadmium. ఇక్కడ కూడా సైజ్ ఇట్లా ఉంటుంది. So now we'll compare the size of the fourth period with the fifth period. कैसे होना चाहिए? बड़ा होना चाहिए या छोटा होना चाहिए? इससे बड़ा होना चाहिए. Why? Because पोटाशियम के नीचे कौन है? रुबिडियम है, right? So the size of rubidium is bit bigger, something like this. So then comes the strontium. So then comes the yttrium. Yttrium is smaller, zirconium is further smaller, niobium is further smaller, but the again the same kind of properties are seen here. The sizes will almost look like same. There is a minor difference between two atoms of any group. So this is what you have to memorize about these periodic properties in the D block elements. Okay, so what shall we do? We'll go to our NCRT, then we'll check. There is a graph given here. We'll talk about that graph here, right? Even actually periodic properties we have already studied in your first year lo చదువున్నాం. అవే మనం రివిజన్ చేయడం అంతే. Right, so here is the variation in atomic sizes, right? So let us go through this. In general, ions of the same charge in given series show progressive decrease in radius with increase in atomic number. So he is talking about only ionic radius. This is because new electron enters a d orbital of each time the nuclear charge increases by 1 unity. It may be recalled that the shielding effect of d electron is not effective. Hence, the net electrostatic attraction between the two nuclear charge and the outermost electron increases. The ionic radius decreases. The same trend is observed in atomic radii given in the series. Ionic radius and atomic radius are the same. However, the variation within the series is quite small. This is the point you should remember. The variation, the decrease found is quite small. It is quietly small. So it's very small. An interesting point emerges when the atomic sizes of one series are compared with those corresponding to the elements with the other series. The curve that shows the 3D 4D series elements of radii of third group. So ikkada okati graph ichadu chudandi. Yeah, we have to understand this graph. So this is trends in atomic radii of transition elements. So transition elements lo these ones are given as this. చూడండి ఇక్కడ the green one corresponds to 4D series. Is it 4D series? So this is 3D series, this is 4D series, this is 5D series, 6D series ఇవ్వలేదు. This ఈ గ్రాఫ్ పైన చాలాసార్లు క్వశ్చన్స్ అడిగారు, right? So on x-axis the radius is taken in nanometers, on y-axis on x-axis the elements are taken, and here what is being taken, the radius is taken. So చూడండి దీంట్లో ఏముంది అసలు చూస్తే. సో వి స్టార్ట్ విత్, సో ఇక్కడ ఎవరున్నారు, స్కాండియం ఉంది, రైట్. ఫస్ట్ ఎలిమెంట్ ఈజ్ స్కాండియం whose size is here, so which is almost 16 picometers, right. Then comes the titanium whose size is almost 14.5 hai. So this is vanadium, so whose size is 13.5, and here comes the chromium, so whose size is like this, almost 13 se thoda zyada hai. Chromium tarvata manganese, size is decreasing but the decrease in the size is very less, right. So manganese tarvata iron ochindi, so this iron is going to be equal to this part. मैंने सबको एक एक लाइन ड्रा कर रहा हूँ, तो यहाँ पर और एक लाइन ये दोनों को टच करके जाएंगे, यहाँ पर आके देख लीजिए, राइट. सो दीज आर द लाइन्स गिवन अस हियर. సో దిస్ ఈజ్ అవర్ స్కాండియం. చెప్పండి అమ్మా, దీంట్లో బిగ్గెస్ట్ ఆటమ్ ఎవరు? ద బిగ్గెస్ట్ వన్ ఈజ్, ద బిగ్గర్ వన్ ఈజ్ స్కాండియం విత్ 16 పికోమీటర్స్. 16 పికోమీటర్స్. దాని తర్వాత సెకండ్ బిగ్గెస్ట్ ఈజ్ టైటానియం. హియర్ ఈజ్ ద టైటానియం. టైటానియం 14 కు 15 కు మధ్యలో ఉంది, అంతేనా. సో ఇట్స్ వీ కెన్ టేక్ ఇట్ యాజ్ 14.5. You can take it as 14.5 ले सकते हैं आप, right. So then comes the vanadium. Vanadium between 13 and 14. So vanadium you can take it as 13.5. And chromium is 13 point something, 13.2 ले लो, right. Then the chromium and copper, చూడండి ఇక్కడ chromium and copper have got almost same sizes. చూడండి ఇక్కడ they have got almost same sizes. So then the manganese, right. So here vanadium and zinc has got almost same sizes. ఈ లైన్ రాంగ్ ఇచ్చాను నేను. So this vanadium and copper have got almost same sizes. Okay. So first rank లో ఇది వస్తుంది, సెకండ్ ప్లేస్లో ఇది వస్తుంది, థర్డ్ ప్లేస్లో వెనీడియం వస్తుంది, యాజ్ వెల్ యాజ్ జింక్ వస్తుంది, రైట్. సో దిస్ కమ్స్ ఇన్ ద ఫోర్త్ ప్లేస్, ఫిఫ్త్ ప్లేస్. సో దిస్ ఈజ్ సిక్స్త్ ప్లేస్, దిస్ ఈజ్ సెవెంత్ ప్లేస్, అగైన్ దిస్ ఈజ్ ఎయిత్ ప్లేస్. ఇవి రెండు ఆల్మోస్ట్ సేమే ఉన్నాయి. cobalt and nickel have got the same sizes, right. సో ఇప్పుడు చెప్పాలమ్మా, మీరు ఆన్సర్ చెప్పాలి. ద స్మాలెస్ట్ ఆటమ్ ఇన్ 3D సిరీస్ ఈజ్, ఎవరు కావాలండి చెప్పాలి ఆన్సర్. ద స్మాలెస్ట్ ఆటమ్స్ ఆర్ cobalt and nickel. These are the ones which are there here. Just I remove all these drawings. So this is how you should remember. The smallest ones are these two, right. So bigger is the scandium, that is not the point here. Okay, right. So next we'll go to 4D series. 4D series has got yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium, right. So these are the elements. So these elements are given like, ఇక్కడ చిన్న స్క్వేర్లో ఇచ్చాడు చూడండి. సో 3D elements are shown by a small circle, 4D elements are shown by small, what do you call, square से denote किया है. So they are like this. The same pattern is followed here. What can you see here? ఇక్కడ కూడా you can observe the smallest atom ఏది కావాలండి దీంట్లో కూడా. So the smallest atoms are going to be చూడండి So the smallest ones are ruthenium and rhodium, right? The smaller ones are ruthenium and rhodium. So this point you should remember. Ruthenium and rhodium. Ikkada evaru unde? Cobalt and nickel are the smallest ones. So here this is quite regular. Then what happened here? If you compare the 3D series and 4D series, the size of 4D series is bigger, isn't it? So ikkada highest size in scandium, highest size of the scandium is this much, but here it is further bigger. So ikkada ochindamma 17, almost 17 picometers ke barabar hai. Which one is yttrium? Yttrium has got this much size. Okay, so this is the point you should remember. Right. So this is about 4D series. The sizes are again same. They are decreasing, they are decreasing, decreasing, decreasing. Then the small increase is found here. So ikkada zinc lo enduku increase avutundi, copper lo enduku increase avutundi ante reason okatenamma D10 configuration. So D10 configuration in 3D subshell makes it bigger because completely filled. So it has got the pseudo octet configuration, that's why they are bit bigger. Okay. So next we will talk about the next one, that is 5D series. Cheppandamma 5D series lo kuda the same pattern is found here. There is a decrease, but the decrease is also the same case. But here these ones are shown by triangles denoted. Everything is denoted by the triangle. So this is the lanthanum, hafnium, tantalum, tungsten, rhenium, osmium, iridium, platinum, gold and mercury. Platinum, gold, mercury. But you can notice one point here. There is a gap between 3D series and 4D series. So this is 3D series, this is 4D series. There is a gap between them. But the gap between 4D and 5D series, 4D and 5D series is very less. So this is the less gap. What is the meaning of it? చెప్పాలమ్మా ఒకసారి చూడండి. ఇక్కడ you can understand here, this is the scandium and this is yttrium, this is lanthanum. ఫస్ట్ ఎలిమెంట్స్లో ఆల్మోస్ట్ సేమే ఉందమ్మా. డిఫరెన్స్ అనేటటువంటిది ఆల్మోస్ట్ వీ హ్యావ్ సేమ్. దిర్ ఇస్ నో మచ్ డిఫరెన్స్ హియర్. ఆల్మోస్ట్ సేమే ఉంది, కొంచెం తగ్గింది ఇక్కడ. బట్ వెన్ ఇట్ కమ్స్ టు టైటానియం అండ్ జిర్కోనియం, ద డిస్టెన్స్ ఈజ్ వెరీ హై. బట్ జిర్కోనియం అండ్ హాఫ్నియం ఆర్ ఆల్మోస్ట్ సేమ్. వీటి మధ్యలో సైజ్ అనేటటువంటిది వెరీ లెస్ ఉందండి. వాట్ కెన్ యూ ఫౌండ్ హియర్? ప్లీజ్ ట్రై టు అండర్స్టాండ్ ద గ్రాఫ్ హియర్. గ్రాఫ్ పైన క్వశ్చన్స్ చాలాసార్లు అడిగారు. we expected like 5D series supposed to be like this. It could have been like this, right? ఇలా ఉండాల్సింది, రైట్? సో దీన్ని కనుక మనం ఎరేంజ్ చేసేస్తే చూడండి. సో వీ ఎక్స్పెక్టెడ్ లైక్ దిస్. ఇట్లా ఉంటే రెగ్యులర్ ఉంటుండండి ఇది. ఇఫ్ దిస్ ఆర్డర్ ఈజ్ లైక్ దిస్, if the order is like this, then this could have been very regular size. Right? So itla unte, so this is 5D series, so this is 5D series, this is 4D series, this is 3D series. We expected 5D series right over here, but where is the 5D series? Not here. The gap between these two are very decreased, right? So ఇప్పుడు ఆ క్వశ్చన్ ఏంటంటే, So gap between 4D and 5D is been decreased. That's true, right? 4D 5D series gap has been decreased, right? So what do you expect here? So 3D series element ila unte you expected 4D series element bigger and the next one is further bigger like this, but what happened, the third one is just bigger than this or almost same than this. ऐसा कुछ है ये इलांट सिचुएशन వచ్చింది. సో ఇక్కడ అబ్నార్మల్ రేడియస్, abnormal radii किसका है? abnormal radii, is it for 4D series or 5D series or 3D series? చెప్పాలమ్మా, ఆన్సర్ చెప్పాలి. చెప్పండి, అబ్నార్మాలిటీ ఎవరికి ఉంది ఇక్కడ? 3D series is regular, there is no problem with this. 4D series is also regular, there is no problem with it. But 5D series expected to be bit bigger than this. But ఇక్కడ చూడండి, so zirconium and hafnium sizes are almost same. ఇక్కడ చూడండి ఒకసారి, సిల్వర్ అండ్ గోల్డ్ సైజెస్ ఆర్ సేమ్. సిల్వర్ అండ్ గోల్డ్ సైజెస్ ఆర్ సేమ్, ఆల్మోస్ట్ సేమ్. దే ఆర్ ఓవర్లాపింగ్ విత్ ఈచ్ అదర్. cadmium mercury sizes are overlapping. So cadmium mercury sizes are exactly overlapping on each other, right? So here the abnormal atomic sizes is found in 4D series, right? 4D series is abnormal series. దీనికి రీజన్ ఏంటంటే, so between lanthanum and hafnium we have 14 elements which are called as lanthanides. We have 14 lanthanides between lanthanum and hafnium. ఇక్కడ చూడు, lanthanum yttrium sizes are regular, almost ఇది పెద్దగా ఉంది, ఇది చిన్నగా ఉంది. సో ఇట్ ఈస్ ఆల్సో లైక్ ద సేమ్, కొంచెం తగ్గింది. ద డిస్టెన్స్ ఇక్కడ 5 ఉంటే ఇక్కడ 4.5 ఉంది అంతే. బట్ ఇక్కడికి వచ్చేసరికి ద డిస్టెన్స్ బిట్వీన్ టైటానియం అండ్ జిర్కోనియం ఈజ్ దిస్ మచ్, వెరాజ్ జిర్కోనియం అండ్ హాఫ్నియం ఈజ్ ఆల్మోస్ట్ సేమ్. దేఖ్ లీజిए, ఇట్ ఈస్ ఆల్మోస్ట్ సేమ్. సో దీనికి రీజన్ ఏంటంటే, దీస్ 14 lanthanides which enter right after lanthanum. This is lanthanum, so this is hafnium. So after lanthanum we have 14 more elements. 14 more elements are there between lanthanum and hafnium. That is why, and lanthanides have got f orbital incompletely filled. So it is 1 to 13 तक होगा या 14 तक भी होगा. And f orbital has got the poor shielding effect. F orbital has got poor shielding effect, right? So that is why lanthanides size, elements preceding lanthanides have smaller sizes. That's why this abnormal radii is called as lanthanide contraction. Is called as lanthanide contraction. Is called as lanthanide contraction. మొత్తం గ్రాఫేనమ్మా, గ్రాఫ్ మొత్తం వస్తే, గ్రాఫ్ రీడింగ్ వస్తే యూ కెన్ ఆన్సర్ ఎనీ కైండ్ ఆఫ్ క్వశ్చన్, right? So I'll recommend everyone, I'll ask everyone to draw the graph as it is given here. So I'll give you 2 minutes time. आपको एक बार ड्रा करना है, एलिमेंट्स भी ड्रा करना है पूरा. You have to check this, then only you will understand it. దీంట్లో JEE questions we will see, direct questions were asked from the graph. So because individually it is not possible for us to remember the atomic radius of every element and all that, right? That's why the graphs makes these things very easier. So the purpose of the graph, so the purpose of any graph is to simplify the data and we read it properly. So that's why you have to draw it. So ikkada why this red line is close to the blue line? Simple reason amma enti reason cheppandi, lanthanide contraction. Lanthanide contraction. Very fancy word ఇది. Lanthanide contraction లో what is the definition of the lanthanide contraction? The steady decrease in size of atoms and ions after lanthanides is called as lanthanide contraction. It is due to completely filled f orbital with the poor shielding effect. Is the reason why this is so. Okay. So if you have taken up tough, so we will see what is actually given here. So ఇక్కడ చూడండి, so what is given here, the curves in figure 4.3 show that increase from left to 3D to 4D series of the elements, but the radii of third series, that is 5D series, are vertically same, so as this corresponds to members of the second series. This phenomena is associated with intervention of 4f orbital, which must be filled before 5D series elements begin. So that's the reason why it is so. The filling of 4f orbital before 5D orbital results in regular decrease in atomic radii. The filling of f orbital before 5D orbital results in regular decrease in atomic radii called as lanthanide contraction, which essentially this is going to compensate for the expected increase in the atomic size with increase in atomic number. So the net results of lanthanide contraction is the second and third D series exhibit similar radii. ఇక్కడ చూడు, ఇక్కడ రెండు ఎగ్జాంపుల్ కూడా ఇచ్చాడు. Zirconium is 160 picometers and hafnium is 159 picometers. This we have seen here. So ఇవి రెండు ఇక్కడనే ఉన్నాయి కదమ్మా. This is here. Exactly the scale లేదు కాబట్టి మనకు almost they are close to each other. Zirconium is 160 picometers. So zirconium is 160 picometers. Hafnium is 159 picometers. Why this example is given? Zirconium is the first element. Lanthanides tarvata, after the lanthanides, the very first member is the zirconium. After actinides, the very first member is the hafnium. That's why their sizes are equal. So there was a question in the JEE, like JEE question ela vesaru ante, which of the following have got almost same size? So question lo option enti zirconium and hafnium ichadu. Why zirconium and hafnium have got same sizes? The reason is lanthanide contractions. These two elements are the very first members of D block elements after lanthanides and actinides. right? No, zirconium, no, hafnium is the first member of it. Sorry, I wrote it wrong. So we don't have the actinides here, right? So here, what is here? So hafnium, lanthanum is like 59, I think, right? 39, 59. Lanthanum tarvata we have got 14 elements. Then comes the hafnium, right? So lanthanum tarvata vachindi kabatti hafnium size is smaller. ఇది hafnium expected to be here, అందుకే ఇది ఇక్కడ క్లోజ్కి వచ్చేసింది, దీని దగ్గరకు వచ్చేసింది. రీజన్ lanthanide contraction. చూడమ్మా, దిస్ ఈస్ ద JEE క్వశ్చన్. విచ్ ఆఫ్ ద ఫాలోయింగ్ హ్యావ్ గాట్ ఆల్మోస్ట్ సేమ్ సైజ్ ఆర్ సిమిలర్ రేడియై? జిర్కోనియం అండ్ హాఫ్నియం హ్యావ్ గాట్ ఆల్మోస్ట్ సేమ్ సైజ్. ఇంకొక పేరు కూడా కనిపిస్తుంది చూడండి, ఇక్కడ ఒకటి కూడా ఉంది చూడండి. సిల్వర్ అండ్ గోల్డ్ ఆల్సో హ్యావ్ గాట్ same kind of structure. So these elements, cadmium, mercury also have got some sizes, whereas the remaining ones are just differing by half picometer or a quarter picometers. The remaining are very much clear. So and have very similar. So due to these sizes, they have similar physical and chemical properties much more than the expected on the basis of usual family relationship. The factors responsible for lanthanide contraction is somewhat similar to that observed in ordinary transition series, so and is attributed to similar cause. The imperfect shielding of one electron by another in the same set of orbitals is the reason, right? So the factor responsible for lanthanide contraction is somewhat similar to that of observed in the ordinary transition state and is attributed to similar cause, that is imperfect, that is poor shielding effect of electrons present in the d orbitals. However, the shielding effect of one f electron, 4f electron by another is less than that of d electron by another, and the nuclear charges increase along the series. That's why there is fairly regular decrease in the size of the entire 4f series of orbitals. The decrease in metallic radius coupled with increase in atomic mass results in a general increase in density of the elements. So thus the titanium with 22 atomic mass, and the copper, titanium to copper, the significant increase in the density may be noted. The density की बात हो रही है, यहाँ तो ये है. Okay, so we will see here कुछ properties दिया हुआ है, just we'll go through it. Atomic numbers of third group elements is given, and electronic configuration 3d1 4s2, ikkada 3d5 4s2 ichadu. So this is how given, and electronic configurations of all the metals is given. Chudandi, one electron is removed from s orbital, and if another electron removed, s orbital doesn't exist, then m+3 corresponds to argon, right? So titanium lo kuda same electronic configurations ichadu. ఇక్కడ చూడండి, ప్రతి ఎలిమెంట్కి సంబంధించినటువంటి ఎలక్ట్రానిక్ కాన్ఫిగరేషన్స్ ఆర్ గివెన్ హియర్. ఎవ్రీ అయాన్స్ electronic configuration is given. Scandium के लिए he has given scandium plus 2, scandium plus 3. Titanium के लिए titanium plus 1, 2, 3 ఇచ్చాడు. వెనీడియం కూడా ప్లస్ 1, 2, 3 ఇచ్చాడు. క్రోమియంది కూడా 1, 2, 3 ఇచ్చాడు. మ్యాంగనీస్ది కూడా 1, 2, 3 ఇచ్చాడు. సో ఎవ్రీ electron you should able to write it. What we have to see is atomic radius सबको पढ़ना है. atomic radius कैसे होगा? Right, next ionization enthalpies కూడా మీరు చూడొచ్చు ఇక్కడ. సో ionization enthalpy, సో 631, 656, 650కి వచ్చింది ఇక్కడికి వచ్చేసరికి. Right? So the reason for 650, why vanadium has less than this one, again the electronic configuration కే attribute చేస్తాం దాన్ని. దీంట్లో D2 configuration ఉంది, దీంట్లో D3 configuration. So again further it increases and increases and increases up to here. Metallic properties are given. The size చూడండి, 64 decreasing, 47, 35, 29, then the sudden increase due to D5 configuration. So then iron 26, 25, iron and nickel have got the same sizes, 25 and 25, copper has got 28 and 37. So ikkada copper nickel both are same unnai, and abnormal atomic mass is found in iron. Iron lo abnormal atomic mass అనేటటువంటిది అటామిక్ రేడియై అనేది కనిపిస్తుంది. సో దీస్ ఆర్ ద వాల్యూస్. ఓకేనమ్మా, అటామిక్ వేరియేషన్ ఆఫ్ అటామిక్ నంబర్స్, సైజెస్ అండ్ ట్రాన్సిషన్ మెటల్స్. Yeah, we'll go to the next property, that is ionization enthalpy. We'll talk about ionization enthalpies. So we have got ionization enthalpies. So we know the definition is as usual. So we call it as ionization energy. So it is the energy required to remove an electron from gaseous neutral isolated atom. Isolated atom is called as ionization enthalpy. Right? So iska factors ఒకసారి చెప్పండి. Ionization energy is affected by, and this is also called as primary ionization energy or first ionization energy. Right? The second one is removal of. So you have got a metal here. You got a metal here. This is the metal which is in the gaseous state. So you have removed one electron. Why this is going like this? So you have got metal, so which is converted into metal plus gaseous state. So here you have to supply the ionization energy 1. Then you get one electron out. And from this, if you supply ionization energy 2, so M plus will become M plus 2. It is going to convert into M plus 2, which is also in the gaseous state. M plus 2 can be converted into M plus 3 gaseous, so by use of ionization energy 3. And we know that ionization energy 3 is bigger than ionization energy 2 followed by ionization energy 1, and this pattern continues till number of electrons present in the molecule, right, or in the atom. The only thing is that you should able to convert the metal into gaseous state, and you have to remove the electron from the outermost orbit, right? So what shall we do here? We will write the electronic configurations of some elements, right? Like, so let us take what manganese, iron letham ani. Iron is converted to iron plus 2. Sorry, iron plus this one first. Iron plus iron is converted to iron plus 1, then iron is converted to iron plus 2, then iron is converted to iron plus 3, iron plus 3 is converted to iron plus 4, iron is converted plus 4 is converted to iron plus 5. ఇలా కంప్లీట్ చేసామనుకోండి, how the electrons are going to be changed. So iron electron configuration is 4s2 3d6, isn't it? So it is 4s2 3d6. When you use ionization energy 1, so what will happen? It has to lose one electron from the s orbital, so its configuration becomes like 3d6 4s1. So then we have to use ionization energy 2, then its configuration becomes like 3d6 4s0. Then you need to use ionization energy 3, so then it becomes 3d5 4s0. If it is 0, you don't have to write it also. So then the ionization energy 4, so it behaves like 3d 4 and 4s0. So again you use ionization energy 5, so it goes like 3d 3 and 4s0. So this is how the electrons are being removed. And when electrons are removed from the neutral atom is bigger. When you remove one electron, so what will happen? The size of it decreases. So this is the size, and iron plus 2 is smaller than iron. Iron plus 2 is further smaller than iron plus. Iron plus 3 is further smaller than iron plus 2. Iron plus 4 is further again smaller. Iron plus 5 further becomes smaller and smaller. So when we remove the electron from the outermost electron orbit, the size of the cation decreases and the outermost electron goes closer to the nucleus and it is held strongly by the nucleus. That's why removal of electron becomes tougher and tougher. That's why more energy is required. Right. So one more point to be noticed here. Whenever you have completely filled orbitals, completely filled orbitals or half filled orbitals, so the electron configuration, this is considered as one of the most stable configurations. So this gives you the highest electronic ionization energy. So out of all these configurations, we can say that this 3d5 configuration is most stable. That's why IE4 is found to be more as compared to IE5 because of this d5 configurations. So this is what about ionization energies, right? So just we'll go through what is given here in the ionization enthalpies. Right. So there is an increase in ionization enthalpy along each series of the transition element from left to right due to increased nuclear charge, which accompanies filling of inner d orbitals. Right. So the enthalpies of first series are given. The values show that the successive enthalpies of these elements do not increase as steeply as in case of non-transition elements. The variation of ionization enthalpy along series of transition metals much less in comparison to variation along the period of non-transition elements. The first ionization enthalpies in general increase, but magnitude of increased in second, third ionization enthalpies successive elements in much higher long series. Some irregular trends The irregular trend in the first ionization enthalpy of a metal 3D series through lattice chemical significance can be accounted for considering that of removal of one electron alters the relative energies between 4s and 3D orbitals. You have learnt that d block elements from ions ns are lost before n minus 1 d orbital. As we go along the period of 3D series, so we see that the nuclear charge increases from scandium to zinc, but electrons are added to the orbitals in the inner subshell, that is 3D subshell. So this is all the matter given here. Something is mentioned here. However, trend steady increase in second, third ionization enthalpies breaks for formation of Mn plus 2, Mn plus 3 respectively. Why? Because they will get D6, D5 configuration. Mn plus 2 has got D5 configuration and Fe plus 3 has got D5 configuration. So this is because of ions have D5 configuration. Similar breaks occurs at corresponding to the later transition series. The interpretation of various ionization enthalpies for the electronic configurations Dn as follows. Right? So ikkada values చూద్దాం ఒకసారి చూడండి. So ionization enthalpy 1, 2 are given here. So these are the elements. So when we go from left to right, ionization enthalpy increases steeply. There is no irregularity in first ionization enthalpy, it's gradually increasing. But after removing one electron, so ionization energy is almost doubled here, 1235. So this is 1309, this is 1414, 1592. Now the manganese number is less. So manganese is expected to be bigger. Why? Because it has, after removing one electron, it has converted like this. So removal of 4s electron. So first ionization energy in manganese is used to remove the electron from the paired 4s orbital, whereas second ionization energy is used to remove the unpaired electron. That's why it's much lesser. S1 के लिए यूज हो रहा है ना, इसलिए this is found to be very less, right? So but when it comes to the third ionization energy, it is 3260. You can see here it has further increased, it has been doubled, which is again greater than this, right? So what can I write here? So ionization energy 2 is smaller than manganese. Ionization energy 2 is smaller than the ionization energy of ionization energy 2 of iron. This is true. But ionization energy 3 of manganese is greater than the ionization energy 3 of iron. ఇక్కడ చూడండి, ఇక్కడ చేంజ్ అయిపోయింది, ఇక్కడ ఈక్వేషన్ చేంజ్ అయింది. ఇక్కడ ఎవరు గొప్ప? ఐరన్ ఈజ్ బిగ్గర్ సెకండ్ అయోనైజేషన్లో, బట్ హియర్ ద manganese is bigger. Why this is happening? Because of this completely filled d orbital. Okay. So then gradually increases, right? So we have only up to third ionization energies only. Okay, so this is ionization energies. So some other information is also given, you have to go through it properly, then you will understand it. The same thing is explained here, just I'll go through it, then we'll conclude the class. Electrons exchange energy. Exchange energy is responsible for stabilization of energy. Why d5 configuration is most stable? d5 configuration has got all electrons unpaired. So 1, 2, 3, 4, 5. So these electrons can be exchanged with one and another. So there are 4 exchanges with the first electron, and there are 3 exchanges with the second electron, 2 exchanges with the, so here you have 3, here you have 2, here you have 1. So total 10 exchanges are possible, that's why it is the most stable. The exchange energy is approximately proportional to the total number of possible pairs of parallel spin in degenerated orbitals. When several electrons occupy set of degenerate orbitals, the lowest energy state corresponds to maximum possibility of extent of single occupation of orbitals and parallel spins. The loss of exchange energy increases stability. The loss of exchange energy increases stability. As stability increases, the ionization becomes more difficult. There is no loss of exchange at D8 configuration. Mn plus has 3d5 4s configuration, and configuration chromium has got d5 configuration. Therefore, ionization enthalpy of Mn plus 2 is less than the ionization energy of chromium plus 1. In the same way, iron plus 2 has got d6 configuration, and manganese plus 2 has got d5 configuration. So hence ionization enthalpy of iron plus 2 is less than the ionization enthalpy of manganese plus 2. In other words, we can say that the third ionization enthalpy of iron is lower than that of manganese. Right? So the lowest common oxidation state of all these elements is plus 2 from its gaseous atoms. The sum of the first and second ionization enthalpies are required in addition to these ones. Right? So this is about the remaining ones. Okay. So we'll go to our PY